from all these extreme calculational and trick problems, okay, and let them go. Of course, here the trouble is again external pressures. One is that nowadays students have this pressure that if you don't get 100% marks, then you are not going to get into any decent place, which is a very strange situation to be in. And the other is the pressure of competitive exams like the JEE. So these are creating extra pressures which make it very hard to deal with these problems. And I understand that, in fact, I don't see really what individual teachers can do to make a difference against these pressures. Probably the solution is that we don't stay as individual teachers, and we have to see what kind of revolt we can launch against these things. I can't just say okay, this is the fault of schools. I also have to see okay, what are we doing at university level, and when a child comes to us, are we being realistic in what we expect them to be able to do once they are with us, and what special steps are we taking to make up. Because whatever improvements are made at the school level, there will always be diversity of boards, of states, of people from different kinds of background, and we'll have to deal with them. And we must deal with them, and we have to figure out what's a good way to do that. What I've been trying to manage to do in my department is an experiment where we basically try to act as if they have not learned calculus, and we first put them through a course called pre-calculus, which takes them back to what are sets and functions and what is mathematical reasoning. Okay, and then builds up to what are numbers, real numbers and limits before we let them then go and do calculus. And we also then have a course specially sort of thought of to deal with this sort of diversity and individual needs, which is just a course called a tutorial. And all we do there is, it doesn't have a set syllabus. Depending on what students we get, we deal with them individually, and we set them problems or ask them to read something, or teach them what, and try and get them to consciously realize okay, what are the expectations now, what were they before, and what do they have to consciously change about the way that they think about mathematics to be able to do better at the higher levels. So, okay, I don't really have a good conclusion. I mean, as a maths lecture, one likes to finish with a theorem or a strong conclusion. I unfortunately don't have that. One of the things that bothers me is that, we do have this idea that maths is special because of the precision that it has and the perfect reasoning that it has. But I wonder if by overplaying that, we are just intimidating people into not being able to think at all. I mean, if all that works is perfect thinking, and then is it, what can you do? I mean, how can one think perfectly? So I think too many people, the idea that it's your common sense and so on that should also be strong, and you just keep making that stronger until you can deal with these things. I don't know how to get that across. Maybe I'm not even putting it properly, but I think I'll stop here. I probably need to learn more from the people who are present here. So
I will not take very long. I'll be brief since you've already heard me quite a bit. But I did find what Professor Amber Habib spoke just now at some length. It's quite interesting, and I think it's, if I may take the liberty to just make some remarks on it, I think it shows in some sense, at the university level, people, teachers, have the freedom to design the coursework, the teaching to a greater extent than school teachers. So it's very nice to hear the university teacher reflect on what is it that we are trying to achieve when we teach some courses, and how can we best do that. I think this is a nice thing, I think, for people working in school education to learn, that we have some goals. We want children to learn certain things. How do we design our teaching? Of course, we don't have so much say in changing the textbook or the curriculum, But we can still think, I think, what is the best way to bring about that learning? And that's, I thought, quite nice. It set me thinking when Professor Habib was talking. Okay. The theme of this panel is gaps. Gaps in teaching and learning, but with the permission of my other panelists and with your permission, I'd like to interpret gaps a little more broadly and say a little bit about that. Firstly, of course, there are what are the gaps that are perhaps the most important, most troubling gaps which we need to address. I think I would just like to flag some of those things and not maybe offer solutions, because maybe we need to solve these things together. I don't really have ready-made solutions. But what are these most important gaps? Some of the research in education, I would say recent research in the last 10, 15 years, and of course this is research largely coming out of advanced countries like America, points to the importance of preschool education. They are saying that studies show that preschool education gaps are very difficult to close. And this is something that we should take note of. I'm not sure whether this is relevant for our society and culture as much as it is relevant for advanced developed countries. But it is something that we should take note of and also reflect on. Because I think that one of the big gaps that we have in our country is the gap between those who come from families which are better off, the haves, and those who come from families which don't have access to much resources. So this is a huge gap. I mean, those who have resources are able to forge ahead, they're able to go ahead. Those who don't have resources, for various reasons, various kinds of resources, are left behind. I think this is a gap that we need to take very seriously, and I don't know how we are going to solve this. And this is, of course, partly, I would say largely, it's the problem of poverty. That children from poor homes have a much more difficult time. So what can we do? I'm not sure, but at least we should acknowledge that this is perhaps the largest and the most troubling gap. Maybe there are issues of nutrition that need to be addressed. Maybe there are issues just caused by poverty alone. When a family is poor, the struggle is harder. The children have less time, less mental space to devote to learning. When they come to school, they may not be free, their minds may not be free. So this is, there may be many kinds of reasons, and I think we need to be sensitive to that. I said. The other gaps that I would like to talk about, of course, there are many gaps which, as teachers, you are aware of. As children go from the early primary classes up to middle school to high school, they encounter some hurdles. The gap may be large between class 5 and class 6 or some two other classes, and children may find it hard to bridge this gap. You are quite aware of that, and I don't really need to speak about that. I think teachers are grappling and struggling with these gaps. But another gap that I would like to focus on, and which I think is important for the theme of this conference, which is teachers of high quality, high capability, who can bring about learning, is the gap that the universities give to the students and what they need in order to teach. Now, of course, not all university graduates, that is, not all the people who get BSc or all the people who get MSc are going into teaching. Of course not. Many of them will not come into teaching. But a good number, a good proportion, significant proportion come into teaching at different levels. It might be school level, primary, middle school, high school, or college. However, I do feel that the university teaching, the university education, does not prepare them in any way to become good teachers. And this is something that we need to pay attention to. Is it possible for our university education to take into account what teachers need? For example, let's take the problem of mathematics. To teach mathematics even at the elementary level, that is at the primary school or middle school level, you need to be strong in content knowledge. You need to know mathematics very well. But not the kind of mathematics which is taught in BSc. Maybe some of the general principles are good that you learn in BSc are also applicable at the elementary level. But you need a deeper understanding and deeper knowledge of the mathematics at the elementary level itself. And somehow our universities don't seem to prepare their students for this. And I think this is something that can be done, not very difficult. Provided the universities acknowledge that this is a problem, they say yes, we agree, and they take the responsibility to solve this problem. I think that's one thing that can be done. Finally, I'd just like to talk about another gap, which I think is important for us as educators. As I said, I'm taking the liberty to interpret the term gap somewhat liberally, and not just the gap of learning at different stages of mathematics. But this gap I'd like to focus on is the gap between the potential and achievement. I see when I interact with teachers, with educators, with teacher educators, with researchers, I see a tremendous potential in our community. I think people are generally very well aware of issues. They are creative, they have solutions, they have ideas, and they are quite committed and engaged. But somehow this does not translate into changes in the actual situation. Why does this happen? I think it is something for us to think about. I mean, even in this conference, what I have heard has been impressive. The papers that have been presented, the plenary talks are excellent. Even just now, I'm coming from a parallel session on PCK. There were 3 papers which were all raising important issues, and I think they were very good papers. And as a community, how do we use this potential we have in order to bring about real change? I think this is something we need to give more thought to. And realize our own potential. Maybe we underestimate our potential. And we should not underestimate. I think that is a very bad mistake. We should be aware of the potential we have and the capabilities we have, and try to make sure that those capabilities make a difference in the world and they solve some problems. Thank you.
There are certain gaps in curriculum itself in school, I feel. For instance, take a case of indices. We all teach and learn indices essentially for the positive integral index, but freely use it for fractions without bothering about the rationale behind it. We use in questions a raised to power 3 by 2 and b raised to power 5 by 6 and all that, but never it is explained the very meaning of what is a raised to power 3 by 2. The definition only a is multiplied so many times. So many times make a sense only when it is a positive integer, that too more than 1. And unfortunately, there are many books, even teachers, try to prove a raised to power 0 is 1. Actually, the fact is, a raised to power 0 is 1 is a definition, not by any argument. But they argue it because it's never defined in school curriculum. I don't know why. It can be defined very easily. A raised to power 0 is 1, a raised to power minus 1 upon a can be defined. But it is proved because no definition is given. proved wrongly, in fact, invalid proofs given. So that is a gap on the part of the curriculum itself, which becomes a gap in the learning also, understanding also. Similarly, in 11th-12th standard, in calculus, there are problems asked about testing differentiability into continuity. But nowhere the definition of limit as epsilon delta is given. It's ridiculous. Unless this definition is given, the testing of differentiability is no use. So the curriculum must include definition of limit as with epsilon delta. It's not included at all. Then coming to other ideas, very few students or even teachers distinguish between the idea between proof and verification. Most of the students think proof is same as verification and vice versa. So somehow now they have brought it in your books in 11th standard, but it is also not examination unit, so it is not taught in the class at all. Then Pythagoras theorem.
Proof and verification.
They don't distinguish. Pythagoras theorem, when it is used, actually we use only the converse, not the theorem itself. But mostly they say by Pythagoras theorem, it is like this. The argument is not by Pythagoras theorem, it is by converse of Pythagoras theorem. So the gap is there in understanding the converse and the main theorem. And partial fraction, it is not included anywhere. They don't learn it separately. It's only when they start doing integration, it is used. So I feel that it should be taught separately in some 7th or 8th class. It can be taught easily. It was there earlier, long back, but now it is removed. It is a gap in curriculum, I feel. So this way there are some gaps in curriculum, some are gaps in understanding, some are gaps in, sometimes teachers give shortcuts or something. Shortcuts also makes gaps. The real things doesn't come out. So, for example, the long square rooting for long division is seldom taught clearly. I have seen many students studying in 11th class. If I ask them to find the square root of some big number, they only factorize it. They don't know the long division. They have forgotten it. They don't know it. So that long division square root is not emphasized in the beginning. So these are the gaps I feel it is really disturbing the students. Of course, the gap between the school terminus and the college beginning is wide. As a teacher, I found those students come for first year, a huge gap between what they learned in 12th class and what to begin in first year of mathematics. For no part of them, they are suffering. So something has to be done about it in curriculum, then by teachers. And the biggest problem is coaching classes. They give only tricks. They don't give fundamentals. Of course, that is not fault of us. It is fault of the parents who send them there.